Dear children, welcome to today's episode. Our today's topic of discussion is to determine pH of solutions obtained from fruit juices, acids, bases, salts using pH paper or universal indicator. विद्यार्थियों, आओ सब तो पहला अपने एम दे नाल शुरू करिए. Experiment, which is to determine the pH of some solutions obtained from fruit juices, acids, bases and salts such as orange juice, tomato juice, vinegar, washing soda, soap solution, milk, common salt, etc. using pH paper or universal indicator. ਵਿਦਿਆਰਥੀਓ, ਤੁਸੀਂ ਪਹਿਲਾਂ ਹੀ ਆਇਓਨਾਈਜ਼ਡ ਸਾਲਟ ਅਤੇ ਇਸ ਨੂੰ ਇੱਕ ਸੋਲਵੈਂਟ ਵਿੱਚ ਡਿਸੋਲਵ ਕਰਨ ਤੇ ਬਣੇ ਆਇਨਸ ਦਰਮਿਆਨ ਡਾਇਨਾਮਿਕ ਇਕੁਇਲਿਬਰੀਅਮ ਨਾਲ ਸੰਬੰਧਿਤ ਐਕਸਪੈਰੀਮੈਂਟਸ ਕਰ ਚੁੱਕੇ ਹੋ. ਅੱਜ ਦੇ ਇਸ ਐਪੀਸੋਡ ਵਿੱਚ ਅਸੀਂ ਅਨਆਇਓਨਾਈਜ਼ਡ ਵਾਟਰ ਮੋਲੀਕਿਊਲਸ ਅਤੇ ਹਾਈਡਰੋਜਨ ਅਤੇ ਹਾਈਡਰੋਕਸਿਲ ਆਇਨਸ ਦਰਮਿਆਨ ਆਇਓਨਿਕ ਇਕੁਇਲਿਬਰੀਅਮ ਵਿੱਚ ਸ਼ਿਫਟ ਬਾਰੇ ਵਿਚਾਰ ਕਰਾਂਗੇ. ਕੰਡਕਟਿਵਿਟੀ ਐਕਸਪੈਰੀਮੈਂਟ ਸਿੱਧ ਕਰਦੇ ਹਨ ਕਿ ਪਿਓਰ ਵਾਟਰ ਵੀ ਕਿਸੇ ਹੱਦ ਤੱਕ ਆਇਓਨਾਈਜ਼ ਹੁੰਦਾ ਹੈ, ਹਾਲਾਂਕਿ ਇਸ ਦੀ ਕੰਡਕਟਿਵਿਟੀ ਬਹੁਤ ਹੀ ਲੋ ਹੁੰਦੀ ਹੈ. ਇਸੇ ਆਧਾਰ ਤੇ ਇਹ ਕੈਲਕੂਲੇਟ ਕੀਤਾ ਜਾ ਸਕਦਾ ਹੈ ਕਿ ਪਿਓਰ ਵਾਟਰ ਵਿੱਚ ਵੀ ਆਇਓਨਿਕ ਇਕੁਇਲਿਬਰੀਅਮ ਐਗਜ਼ਿਸਟ ਕਰਦਾ ਹੈ. ਇਸ ਆਇਓਨਿਕ ਇਕੁਇਲਿਬਰੀਅਮ ਨੂੰ ਸਕਰੀਨ ਤੇ ਇਸ ਤਰ੍ਹਾਂ ਦਰਸਾਇਆ ਜਾ ਸਕਦਾ ਹੈ. Since hydrogen ion cannot have independent existence in water because of its positive charge and small ionic radius, a better representation of this equilibrium is as shown. This means that water dissociates into hydronium ions and hydroxyl ions. This is self-ionization of water. Equilibrium constant for this chemical equation can be written as shown on screen. Equilibrium constant K is equal to concentration of hydronium ions multiplied by concentration of hydroxyl ions whole divided by concentration of water. Since water is in large excess, its concentration can be assumed to be constant, and combining it with K provides a new constant Kw, which can be written as shown on screen. Children, here Kw is self-ionization constant of water, or simply ionization constant of water. It remains constant at constant temperature. At 25 degrees Celsius, value of Kw is 1.0 multiply 10 raised to the power minus 14. So, it is quite evident that at a given temperature in any aqueous solution, this product, that is, product of hydronium ion concentration and hydroxyl ion concentration remains constant, whether the solution is acidic, alkaline or neutral in nature. If dissolution of a substance shifts the equilibrium in such a way that at equilibrium concentration of hydroxyl ions is greater than the concentration of hydronium ions, then the solution is alkaline in nature. Thus, concentration of hydronium ions in an aqueous solution can provide information about acidic, basic and neutral nature of the solution. The concentration of hydronium ions in a solution is measured in terms of pH, which is defined as the negative logarithm of hydronium ion concentration and is given by the expression you are seeing on the screen. At room temperature, pH of neutral water is 7. A solution with pH less than this is acidic, while the solution with pH greater than this is basic in nature. This means that the pH of a solution is defined as negative logarithm of hydrogen ion concentration. The pH of different solutions is determined by putting a drop on pH paper and observing the color. The color is subsequently matched with color chart having color corresponding to the standard given values of pH. ਵਿਦਿਆਰਥੀਓ, ਕੀ ਤੁਸੀਂ ਇਸ ਦੇ ਪਿੱਛੇ ਦੀ ਥਿਊਰੀ ਬਾਰੇ ਜਾਣਦੇ ਹੋ? ਆਓ ਇਸ ਤੇ ਵਿਚਾਰ ਕਰੀਏ। ਬਹੁਤ ਸਾਰੀਆਂ ਡਾਈਜ਼ ਡਿਫਰੈਂਟ ਪੀਐਚ ਤੇ ਡਿਫਰੈਂਟ ਕਲਰਸ ਦਰਸਾਉਂਦੀਆਂ ਹਨ। ਇਹ ਐਸਿਡ ਬੇਸ ਇੰਡੀਕੇਟਰਸ ਵਜੋਂ ਐਕਟ ਕਰਦੀਆਂ ਹਨ। ਡਾਈਜ਼ ਦੇ ਮਿਕਸਚਰ ਦੇ ਸੋਲਿਊਸ਼ਨ ਨੂੰ ਕਿਸੇ ਸੋਲਿਊਸ਼ਨ ਦੀ ਅਪਰੋਕਸੀਮੇਟ ਪੀਐਚ ਵੈਲਿਊ ਪ੍ਰਾਪਤ ਕਰਨ ਲਈ ਵਰਤਿਆ ਜਾ ਸਕਦਾ ਹੈ। A solution of a mixture of dyes can be obtained to measure pH values from 0 to 14. It is called universal indicator. Some universal indicators can measure the pH change of even 0.5. In fact, dyes themselves are weak acids or bases. Color change occurs as a result of change in the structure of dye due to acceptance or release of protons. Different forms of a dye have different colors, and hence color change is observed when pH of the solution changes. A standard chart for the color change of the universal indicator with pH is supplied with the indicator paper or solution, and the comparison of observed color change with the chart provides a good estimate of the pH of the solution. आओ एक एग्जाम्पल लईए। रेड कैबेज जूस ਦੀ ਵਾਸਟ pH ਰੇਂਜ ਹੁੰਦੀ ਹੈ। ਇਹ ਐਕੁਅਸ ਸੋਲਿਊਸ਼ਨ ਵਿੱਚ pH ਦਾ ਇੱਕ ਯੂਨੀਵਰਸਲ ਇੰਡੀਕੇਟਰ ਹੈ। आओ pH ਨੂੰ ਸਕਰੀਨ ਤੇ ਵੇਖੀਏ। We also find that color of hydrangeas depends on the pH of the soil in which they grow. If pH of soil is acidic, flowers are blue, and in alkaline pH, flowers are pink.
ਵਿਦਿਆਰਥੀਓ, ਆਓ apparatus ਤੇ ਨਜ਼ਰ ਮਾਰੀਏ। ਇਸ ਐਕਸਪੈਰੀਮੈਂਟ ਦੇ ਲਈ ਜੋ ਚਾਹੀਦਾ ਹੈ ਉਹ ਇਸ ਤਰ੍ਹਾਂ ਹਨ। apparatus, test tube stand, droppers or capillary tubes, glass rod and pH paper. ਅਤੇ ਆਓ ਹੁਣ ਐਕਸਪੈਰੀਮੈਂਟ ਲਈ ਰਿਕੁਆਇਰਡ ਕੈਮੀਕਲਸ ਤੇ ਇੱਕ ਨਜ਼ਰ ਮਾਰੀਏ। ਇਹ ਹਨ pH indicators, color chart, universal indicator solution, solutions of orange juice, lemon juice, tomato juice, vinegar, washing soda, soap solution, milk, common salt, and distilled water.
ਵਿਦਿਆਰਥੀਓ, ਆਓ ਹੁਣ procedure for pH determination using universal indicator solution ਨੂੰ ਚੰਗੀ ਤਰ੍ਹਾਂ ਸਮਝੀਏ।
The collected samples of fruit juices are put in labeled test tubes. We take a dropper. We put 2 to 3 drops of sweet lime juice from the first test tube on a pH paper strip by means of the dropper. We will find that the color of filter paper changes at once. Next, we compare the shade of the color formed with the color chart present on the filter paper book. We see that the shade here matches with the color bar corresponding to pH 4. Next, we put a few drops of tomato juice from the second test tube on the strip of pH paper and compare the change in color of the strip to the color chart. The pH of tomato juice is also found to be 4. In this way, the process is repeated for each juice. The approximate pH of amla juice is 3. This value signifies that amla is more acidic compared to sweet lime and tomato juice. We will next check the pH of pomegranate juice and compare the shade with the color chart and record the approximate pH as 2. For lemon juice, the color of the pH paper will match with the shade corresponding to pH 2. Finally, we check the pH of orange juice. The color of pH paper will match with the color corresponding to pH 3. We then record the observations in the observation table. From the pH values, we infer that all fruits are acidic in nature. For testing pH using universal indicator, we take the given juices and some universal indicator in different test tubes. Universal indicators are made by mixing a number of common indicators. We add 2 to 3 drops of universal indicator solution in each test tube by means of a dropper and shake the test tube well. The solution changes in color. We compare the color change with the color chart on the bottle. The color of lemon solution will approximately match with the color corresponding to pH 2. Next, we put few drops of universal indicator in the test tube containing orange juice and compare the change in color of the solution to the color chart. We observe that the approximate pH of orange is 3.5. The approximate pH of apple juice is recorded as 3.4. Next, we check the pH of pineapple and compare the shade with the color chart and record the approximate pH as 4. For lemon juice, the color of the solution will match with the shade corresponding to pH 2. Finally, we check the pH of orange juice. The color of the solution will match with the color corresponding to pH 3. Observation: record of pH of different solutions using pH paper or universal indicator. Result: increasing order of pH value of juices is 4, 3.5, 3.4, 2. This means that lemon juice is most acidic.
ਵਿਦਿਆਰਥੀਓ, ਆਓ ਹੁਣ ਐਕਸਪੈਰੀਮੈਂਟ ਕਰਦੇ ਹੋਏ ਵਰਤੀਆਂ ਜਾਣ ਵਾਲੀਆਂ ਪ੍ਰੀਕਾਸ਼ਨਸ ਤੇ ਵਿਚਾਰ ਕਰੀਏ। Use different pH paper for each solution. Wash the dropper before using it for next solution. Add equal numbers of drops of universal indicator to equal volumes of solutions in each of the test tubes. Match the color of the solution with pH chart carefully. Store pH papers at a safe place to avoid contact with acidic and basic reagents kept in the laboratory. Use only fresh juice for the experiment.
ਵਿਦਿਆਰਥੀਓ, ਹੁਣ ਤੱਕ ਜੋ ਕੁਝ ਅਸੀਂ ਸਿੱਖਿਆ ਹੈ, ਆਓ ਉਸ ਨਾਲ ਸੰਬੰਧਿਤ ਕੁਝ ਸਵਾਲਾਂ ਤੇ ਵਿਚਾਰ ਕਰੀਏ। My first question is, out of the 4 juices, which one is least acidic? And the answer is, out of the 4 juices, pineapple juice is least acidic. My next question is, if we dilute each of the juices, what effect is likely to be observed on the pH values? And the answer is, if we dilute each of the juices, the pH values will decrease. My next question is, how can you ascertain the pH of a soft drink? And the answer is, pH of a soft drink can be estimated with the help of a pH paper.
ਵਿਦਿਆਰਥੀਓ, ਹੁਣ ਅਸੀਂ ਐਕਸਪੈਰੀਮੈਂਟ ਦਾ ਪਹਿਲਾ ਪਾਰਟ ਪੂਰਾ ਕਰ ਲਿਆ ਹੈ। ਚਲੋ ਹੁਣ ਸੈਕੰਡ ਐਕਸਪੈਰੀਮੈਂਟ ਤੇ ਵਿਚਾਰ ਕਰੀਏ। ਨੈਕਸਟ ਐਕਸਪੈਰੀਮੈਂਟ ਦਾ ਏਮ ਹੈ to observe the variation in pH of acid or base with dilution. ਆਓ ਇਸ ਐਕਸਪੈਰੀਮੈਂਟ ਦੇ ਪਿੱਛੇ ਦੀ ਥਿਉਰੀ ਬਾਰੇ ਜਾਣੀਏ। Children, hydrogen ion concentration per unit volume decreases on dilution. Therefore, change in pH is expected on dilution of the solution.
Children, let us discuss the materials required for the experiment. Boiling tubes 8, glass droppers 4, test tubes as per need, 0.1 molar hydrochloric solution 20 milliliter, 0.1 molar sodium hydroxide solution 20 milliliter, 0.05 molar sulfuric acid solution 20 milliliter, pH paper or universal indicator as per need. ਆਓ procedures ਤੇ ਵਿਚਾਰ ਕਰੀਏ। We take 4 boiling tubes and mark them as A, B, C and D. We then take 2 milliliter of 0.1 molar hydrochloric acid in boiling tube A. Next, we take 2 milliliter of 0.1 molar hydrochloric acid in boiling tube B and add 18 milliliter water to it and mix thoroughly. Then, we take 5 millimeter of dilute hydrochloric solution from boiling tube B in boiling tube C and add 15 milliliter water to it. We now take 5 milliliter of diluted hydrochloric acid from boiling tube C in boiling tube D and add 15 milliliter water to it. Now we cut a pH paper into small pieces and spread these on a clean glazed tile. We then take out some solution from boiling tube A with the help of a dropper and pour one drop on one of the pieces of pH paper kept on the glazed tile and compare the color of the pH paper with the standard chart. Similarly, pH of solutions of boiling tubes B, C, and D are tested respectively, and the results are recorded in the table. We then calculate the hydrogen ion concentration of solution B, C, and D. Next, we take out 1 milliliter of solution from each boiling tube and transfer in separate test tubes and add 2 drops of universal indicator to each of these test tubes. Shake the test tubes well and match the color of these solutions with the standard pH chart to estimate the pH. Similarly, we observe the change in pH of 0.05 molar sulfuric acid and 0.1 molar sodium hydroxide solution with dilution. The observations are recorded in the form of a table. The results obtained are compared by using universal indicator paper and that obtained by using universal indicator solution.
So children, we have learned today about determination of pH of solutions obtained from fruit juices, acids, bases, salts using pH paper or universal indicator. ਵਿਦਿਆਰਥੀਓ, ਹੁਣ ਤੱਕ ਅਸੀਂ ਕਾਫੀ ਕੁਝ ਸਮਝ ਲਿਆ ਹੈ। ਹੁਣ ਮੈਂ ਤੁਹਾਨੂੰ ਕੁਝ ਸਵਾਲ ਪੁੱਛਦੀ ਹਾਂ।
My first question is, define the term pH. What does pH stand for? And the answer is, the term pH is defined as the negative logarithm of hydrogen ion concentration of a given solution, the concentration being expressed as moles per liter. Mathematically, pH equals minus log hydrogen ion concentration. pH stands for power of hydrogen ion concentration, P for power and H for hydrogen ion concentration. My next question is, what is pH scale? Explain briefly. And the answer is, the strength of an acid or a base is expressed in terms of hydronium ion concentration. This is expressed on a scale known as pH scale. It is a 14-point scale. That is, it has values ranging from 0 to 14, indicating the value of negative logs of hydrogen ion concentration of the solution. Some important benchmark values in the pH scale are: pH 7 indicates neutral solutions. Example, aqueous solutions. pH more than 7 to 14 indicates alkaline solutions. And pH less than 7 to 0 indicates acidic solutions. Next question is, what is the pH of pure water and that of rainwater? Explain the difference. And the answer is, the pH of pure water is 7. Rainwater is slightly acidic because as raindrops fall the carbon dioxide in the air dissolves with drops to form very weak carbonic acid. Accordingly, rainwater has a pH that is slightly below 7. Next question is, what is the pH of solution A which liberates carbon dioxide gas with a carbonate salt? Give the reason. And the answer is, the pH of solution A is lesser than 7. Carbonate salts react with acid A to liberate carbon dioxide gas. My next question is, what is the pH of solution B which liberates ammonia gas with an ammonium salt? Give reason. And the answer is, the pH of solution B is greater than 7 because B is an alkali as it liberates ammonia gas. Next question is, how do you increase or decrease the pH of pure water? And the answer is, by adding a few drops of alkali to pure water, its pH increases. And by adding a few drops of an acid, decreases the pH of pure water. Next question is, what are indicators? And the answer is, indicators are chemicals that show whether the given solution is acidic or basic by the sudden change of color. The next question is, name the common acid-base indicators used in the laboratory with their color change. And the answer is, the 3 common indicators used in the laboratory are as shown on the screen. Next question is, what is a universal indicator? What is its advantage? And the answer is, a universal indicator is a mixed indicator of organic chemicals which not only shows whether the given solution is acidic or basic, but also shows the approximate pH values by giving a wide particular color for a specific value of pH.
ਵਿਦਿਆਰਥੀਓ, ਅੱਜ ਦੇ ਲਈ ਬਸ ਇੰਨਾ ਹੀ। ਮੈਨੂੰ ਉਮੀਦ ਹੈ ਕਿ ਤੁਹਾਨੂੰ ਅੱਜ ਦਾ ਇਹ ਪਾਠ ਚੰਗੀ ਤਰ੍ਹਾਂ ਸਮਝ ਆ ਗਿਆ ਹੋਵੇਗਾ। ਅਗਲੀ ਵਾਰ ਅਸੀਂ ਇੱਕ ਹੋਰ ਨਵੇਂ ਵਿਸ਼ੇ ਤੇ ਵਿਚਾਰ ਕਰਾਂਗੇ। ਹੁਣ ਇਜਾਜ਼ਤ, ਬਾਏ।